So now that we've been talking about reactive streams for a bit, and I've talked about different paradigms, we talked at a high level about RxJava versus Project Reactor, let's start taking a more detailed view of the RxJava API. And in particular, we're going to talk about some of the key classes: single, observable, and flowable, and very briefly parallel flowable, which you'll need to understand in order to be able to do Project 5 successfully. The Project 5, by the way, will come out very soon, hopefully either later tonight or by tomorrow. So RxJava has three key classes and then a few variants of those classes. The first one is the single class, and the single either completes successfully or it doesn't, it fails, and it may or may not emit a single value. If it succeeds, it'll give you a value. If it fails, it may not give you a value. You can think of single as being something akin to Java completable future, or maybe even an asynchronous optional. And that's because it just gives a single value back. You can document them, or they are documented by the documentation, which you'll find online, by something called marble diagrams, which are pretty funny names, but you'll see why they call them marble diagrams in a second when we look at the examples here. So in a marble diagram, there's a timeline of either singles or observables or flowables or whatnot, where time flows from left to right. So you can see left to right here. This is the item that is emitted by the single, and the dotted lines in the box below indicate some transformation that's being applied to the single. So something will emit a value. It's kind of like a prior stage in the completion stage model of completable futures. And then there's a transformation that will be applied to it. For example, you could flat map it, you can filter it, you can do various things to the value that's emitted. And the text inside the box indicates the type of transformation that's being applied. And then the item that comes out here at the bottom of the box is the result of this transformation. There's a vertical line that's shown here that indicates the single completed successfully. And if something goes wrong, then the vertical line is replaced by an X. So that's kind of how you read the diagrams. And why this matters is because all of the operators that are defined in RxJava and Project Reactor in the documentation, by and large, use marble diagrams to give you some hints as to the semantics of these operations or these operators. There are a lot of these operators. There's factory methods, transforming operators, things that handle concurrency and scheduling, ways to combine stuff together, ways to block, and so on and so on and so forth. We're not going to talk a lot about singles in this class because we're going to focus more on flowables and parallel flowables and observables, but just be aware that there's singles out there that are useful for certain things. There's also a variant of a single in RxJava called a maybe, which may emit a value, or it may emit nothing, or it may throw an exception. The next type of class that RxJava has is it's really the workhorse of RxJava, and you've really got to understand this one. The other ones we'll talk about are variants of this. And this is something that's called an observable. And it can be used to emit an indefinite number of events, 0 to infinity, forever. And these events it emits may or may not complete successfully, and they may fail. So you can have either success or failure. This is similar to an asynchronous Java stream. You can think of it kind of like a completable future used with a Java stream, which you have got experience with now that you programmed assignment 4. So here's an example where we're going to take a list of big fractions, and we're going to turn that list of big fractions into, an array of big fractions, and we're going to turn that into an observable, and we're going to have that run in a background thread, and then we're going to go ahead and in the background, we're going to multiply and reduce a bunch of these big fractions with some constant, and then we're going to add all the results together. That's what this is showing. So again, if you look at this, even if you're not yet familiar with the details, you can kind of get a feeling of the streams with asynchrony going on here. Observables can also be documented using marble diagram. In this case, we have the timeline where, once again, time flows from left to right, and these are the items that the observable emits, and we can indicate what transformations are applied to them. Remember, an observable can have multiple values, so that's why we have multiple marbles. And the text inside the box indicates the type of transformation that's being applied, like mapping or filtering or various other kinds of operations. And then there are items that are going to be generated as the result of the transformations or filtering that the operator is going to perform. As with before, if everything goes well, then there's a vertical line that indicates all the items were emitted successfully. And if something goes wrong, then the vertical line will be replaced by an X, just indicating that there will be a way to propagate an error or throw an exception or whatnot, whatever the error propagation mechanism is defined as for that particular operator. As with single, there are a very large number of operators, hundreds of them really. Factor methods, transforming operators, action operators, concurrency operators, scheduler operators, combining terminal operators, suppressing operators, blocking operators, and the list goes on and on. We will talk about many of these operators, though by no means all. I'm going to be focusing primarily on the operators you'll need to know in order to do the programming assignment successfully. And we also have flowables, which are a generalization of observable that support backpressure. So out of the box, observable will generate the events, or observables, when they're used, will generate events just as fast as they can be generated. There's no backpressure, there's no flow control. So to handle this, RxJava defines something called a flowable, which supports backpressure. And the subscribers indicate to the publishers how much data they can consume, as we talked about before. And something to note here that's really important, because it figures in quite prominently in assignment number 5, is that a flowable can be converted into a parallel flowable. And a parallel flowable can then operate on multiple streams of data concurrently. So parallel flowables are kind of like combining Java parallel streams with Java completable futures in a very cool way that will simplify the way that you write reactive concurrent code. It's about just a teeny weeny bit more ceremony than parallel streams, but the benefit is you get asynchronous processing sort of for free or at no extra cost by being able to use parallel flowables. So we'll spend a lot of time talking about them. They're very cool, and that will help structure many of the method implementations in the skeleton for assignment number 5. So that's the overview of key classes in the RxJava API. And of course, we will go through these in more detail very soon.